So 39 through 62 are the bottom groupings, the last part of section 5.1's probably going to go on between two videos. And the instructions say solve by completing the square. So completing the square is a technique to solve problems that have squares and equal signs. Duh. And it's a technique that comes up a little bit in college algebra, so you kind of need to know it. Although, most of the problems between 39 and 62 can be solved using strategies that are easier than completing the square. It turns out that solving by completing the square, if you're doing graphs, it tells me something about the graph of the equation that I can't get without completing the square. But completing the square is just a technique for solving problems that have equal signs with the highest exponent of square, and they're a little bit ugly. It has steps. The steps to solve by completing the square is get the constant by itself on the right hand side. And this sometimes is already done for me. Constant being a number without a letter. So I want to get the number without the letter alone. I'll say on the right side. It could be on the left side, but I think for our problems they're all going to be on the right side, and that's kind of common. Step 2 is I'm going to add c to both sides. Step 3 is I'm going to change the c to a number. Step 4, I'm going to lazy factor the left side. I'm going to simplify the right side. And step 5, solve using the square root property by square rooting plus or minus square rooting. That step 5 is more involved, so there's steps to solve with that, but I didn't detail those down. So if I was looking at problem 40, that gives me b squared plus 8b equals 9. Step 1's already done. Step 1 says get the number without the letter alone on the right hand side. That's already done. I don't need to do it for this case. So I'm going to move into step 2 for problem 40, and step 2 says add c to both sides. So done, I added c to both sides. Step 3, I'm going to change c to a number. And I know how to do c. C is based on the number in front of the first power term divided by 2 and then squared. So 8 divided by 2 is 4. 4 squared is 16. So for step 3, I'm going to write this as b squared plus 8b plus 16 equals 9 plus 16. Done with step 3. The reason we did the middle problems is for this step right here. And now I can lazy factor. So I'm going to lazy factor the left-hand side using that number 4. The left-hand side's going to factor into b plus 4 quantity squared. So I'm going to lazy factor the left-hand side, simplify the right-hand side. The right-hand side is 25. Done with step 4. Now we're into step 5, solving by square rooting plus or minus square rooting, which is the first group of problems. So I'm going to square root plus or minus square root On the left-hand side, I just get b plus 4. The square rooting cancels out the square. And on the right-hand side, the square root of 25 is 5. And in these problems where I'm solving with square roots with parentheses, if the right side simplifies, it doesn't have an I and it doesn't have a square root, my best answer doesn't have a plus or minus sign. So I'm going to get this solved now using the square root property. I'm going to minus 4 from both sides and get b equals to minus 4 plus or minus 5. Because there isn't an I and there isn't a square root, I need to go further. The further that I need to go is write b equals to negative 4 plus 5 and b equals to negative 4 minus 5. The negative 4 plus 5 is going to be 1. And the negative 4 minus 5, negative using that, minus using that, is negative 9. So my best answer doesn't have a plus or minus sign. When the right-hand side doesn't have a square root nor an I shouldn't have a plus or minus sign in my answer. These will all check. I don't get extraneous solutions when I'm solving using the square root property. I'll do 41 with you just to save you some homework. So in 41, the first step is to get the number without the letter by itself on the right-hand side. I don't know if 41 is big enough. So 41 is a squared plus 10a minus 24 equals to 0. The number without the letter is this 24. That's the constant. I'm going to get it alone on the right-hand side. So that's what step 1 would be if it's not already done for you. When I started problem 40, step 1 was already done, so I went right into step 2. Step 2 is add c to both sides. That's just a number without the letter without the number. Step 3, change c to a number. C is going to be the number in front of the first power term divided by 2 and then squared. 10 divided by 2 is 5. 5 squared is 25. I'm going to change the c to a 25. On both sides. Then I'm going to lazy factor the left side and simplify the right side. The left-hand side is going to factor into a plus 5 squared. This is why we did those middle problems. The right-hand side, 24 plus 25 is 49. Done with step 4. Now I'm solving by square rooting, plus or minus square rooting. On the left-hand side, I get a plus 5. On the right-hand side, the square root of 49 is 7. When you're solving these square root problems, if the right-hand side had an I or a square root, my best answer would have a plus or minus sign. Here, the right-hand side doesn't have an I, it doesn't have a square root. My best answer doesn't have a plus or minus sign. So I need to solve by the square root property. I'm going to minus 5 from both sides and get a equals to minus 5 plus or minus 7, and then I'm going to make up the two problems implied by the plus or minus. So a is negative 5 plus 7, a is negative 5 minus 7. The negative 5 plus 7, those have opposite signs, so I subtract. The negative 5 minus 7, those have the same signs, so I add. And for my answer, it's going to be a is 2 and negative 12. Kind of tempted to do 43 with you and not do 44, so let's work on 43. 43, since the instructions are to solve by completing the square, I go through these steps. First, get the constant by itself on the right-hand side. And in 43, step 1's already done. Sometimes it's done for me, sometimes it's not done for me. Step 2, add c to both sides. Step 3, change c to a number. C equals negative 10 divided by 2 squared. That's negative 5 squared. Squaring a negative, I get a positive. So C is going to be 25. Step 4, lazy factor the left side, simplify the right side. This number in that parentheses is going to go for my lazy factoring. The right-hand side, I can add those just fine. And now solve by the square root property for step 5. Solve by square rooting plus or minus square rooting. So square root plus or minus square root. The left-hand side, I get a minus 5. I don't need my calculator to square root 100, but you're welcome to use your calculator. When I'm solving by square rooting plus or minus square rooting in the world of parentheses, if the right side had an I or a square root, I'd leave a plus or minus in my answer. If the right side doesn't have an I, doesn't have a square root, I shouldn't have a plus or minus in my answer. I shouldn't have a plus or minus in my answer here. So I'm going to finish this up. I'm going to add 5 to both sides and get a equal to 5 plus or minus 10. And I'm going to make up the two problems implied by the plus or minus, which is a equals 5 plus 10 and a equals to 5 minus 10. 5 plus 10 is 15. 5 minus 10 is negative 5. For my answer, it's a equal to 15 and minus 5. I'll do 46 and leave you 48. So 46, y squared minus 4y plus 3 equals to 0. Step 1, get the constant by itself on the right-hand side. That's the number without the letter. It needs to be alone on the right-hand side. Step 2, add c to both sides. Step 3, change c to a number. C is negative 4 over 2 squared, which is negative 2 squared, which is positive 4. Step 4, lazy factor this side. This side's going to factor into y minus 2 squared. Combine those have opposite signs, so I subtract. And then, last step, solve by square rooting, plus or minus square rooting. On the left-hand side, when I square root, I get y minus 2. On the right-hand side, the square root of 1 is just 1. The right-hand side doesn't have an I, and it doesn't have a square root, so my answer shouldn't have a plus or minus sign. I'm going to add 2 to both sides and get y equal to 2 plus or minus 1. If that 1 had an I or a square root, I would be done right now. But because it doesn't, I make up the separate problems. Y equals 2 plus 1, y equal to 2 minus 1. And get my answer of y equal to 3 and 1. All these will check. I'm saving time and not checking, but you can check all of these. Let's do 47 together. So 47 is x squared plus 2x equals to 6. Step 1, get the number without the letter by itself. That's already done. Step 2, add c to both sides. Step 3, change c to a number. took that 2, divided it by 2, and then squared it. Step 4, lazy factor. I'm using that parentheses right there to pick up my left-hand side factoring. Combine on the right-hand side. Step 5, solve by square rooting, plus or minus square rooting. This is going to give me x plus 1 equals plus or minus the square root of 7. Need to solve for x by minusing 1 from both sides. That gives me x equals minus 1 plus or minus the square root of 7. If the right side has a square root, my best answer has that plus or minus sign. So I would say the best answer for 47 would be x equals to negative 1 plus or minus the square root of 7. An okay answer would be to make up the two problems implied, which would be x equals negative 1 plus the square root of 7 and negative 1 minus the square root of 7. The reason we don't usually write the answer like that is because those terms, they can't be added or subtracted. Those aren't like terms, they can't be combined. And I can see those two answers in the single slick answer. So give 49 a try, I'll do 50. First step, get the number without the letter, the constant, by itself on the right-hand side. Second step, add c to both sides. Third step, change c to a number. Fourth step, lazy factor the left-hand side, and use that number in the parentheses to lazy factor the left-hand side. Combine on the right-hand side. Those have opposite signs, so I subtract them. Negative 24 plus 9 equals negative 15. Last step, solve by square rooting, plus or minus square rooting. Left-hand side, I just get x minus 3. Right-hand side, when I do the square root of negative 15, if I'm in mode 2, my calculator tells me that's square root of 15 times I. I need to get the x isolated. I'm going to add 3 to both sides. And this right here is going to be the best answer. I can't do much better than this. If I separated the plus and the minus into two separate answers, they can't be combined. In the world of these square root problems, if the right side has a square root or an I, or both a square root and an I, the best answer has a plus or minus sign. How about we stop at 53? And maybe I'll do 53 with you in the 2 minutes that I have, and then we'll call it done with this section. So 53b squared plus 6b equals 11. Step 1 is done. The number without the letter is isolated. Step 2, add c to both sides. Step 3, change c to a number. Step 4, lazy factor the left-hand side. Combine the numbers on the right-hand side. Step 5, square root plus or minus square root. On the left-hand side, you get b plus 3. And on the right-hand side, that's a reducible square root. We're in this chapter, we're allowed to reduce square roots in our calculator. The right-hand side is 2 rad 5. I'm going to minus 3 from both sides to get the b isolated. And because that square root on the right-hand side, this is my best answer. If I tried to write it separately and wrote like negative 3 plus 2 square root of 5 as an answer, that doesn't simplify, so there's no need to write that as a separate answer. Similarly, negative 3 minus 2 square root of 5 can't simplify, so I don't write that. My video's got a hiccup. There's some problems on the bottom that I'm skipping, that the c's would be fractions. Not such a big deal. Those aren't terribly important. So let's just go any of the problems 1 to 53 odds in this section. I think we should be good.